when I first started going a couple months ago, getting into here, I started looking through all of the technical data sheets and other things you find around the internet. There's a lot of good information out there, like from Texas Instruments, high speed, and all kinds of like the angles, and looking through these technical documents. And then when you come back to everything down under the hood, it comes down to the product and using the tool, being able to know the tool. And so it's hopefully it's not, when I look at some of the great speakers here, they're talking about all the EMI protection, all of this really great information. I was hoping that I would be able to give some of this, but then it turned out more focused on the product. So hopefully that I know we have a whole range of users, from brand new users to hard heavy hitters who've used the tool. Hopefully Wayne Mitzen is not here with over 3,500 boards. But so whether you've only done 3 boards, 30 boards, or 300, the bottom line is the tool, getting used to the tool, knowing the tool. So we're going to look at basically using Altium Designer and to its most to the maximum benefit. So of course, in the quick introduction, come on in and have a seat. So of course, as PCB designers, you have a very daunting job. So not only do you have to finish your board, but you have to meet, design with the routing challenge. You have to meet all your electrical fabrication and assembly requirements. So it's, which if you see Mike Creeding running around, he has his design for excellence. So if you search him up, he's got a nice presentation that he does on that. And of course, early on, communication between all. I think there's a talk about communication. You talk with your fab house, see what their requirements, what they are capable of doing, what's their minimum requirements. Talk to them early on when if you're doing high speed and you have to figure out what the direction that you're going to route your traces on. They can position the pre-preg, so then that way you route across the weave of the pre-preg. So there's lots of different tricks. Talk to them early on. One of the main keys is looking at the design data sheets. Most, depending on the board you're working, it really depends on the components and chips that you have in the board that's going to drive how you route your board. So look at especially your routing chips. If you're routing a big Xilinx chip, they'll have lots of tips. And versus some op amps or other, everything will have its own particular routing style, and typically they'll even give examples in the board. Of course, early on to talk with your EEs. Early on, if you get your rules defined in the schematic, and make sure that you get all the rules and everything set up. Because getting your, I put this link down here at the bottom for TI. It's going to talk about some nice design techniques for high speed. But if you look on there, like if you're using PCIe or if you're using other types of technology, every technology will have its own style of routing techniques and widths and clearances and things. So you want to make sure you check the individual data sheets. So what I broke down first is the foundation of routing. So first of all, if you've never used Altium, I've been in a class like that where I was teaching at and one guy was saying, well, what's your definition of a PCB? He was more of the scientist and building it, and then he was also tasked with helping to build the PCB. So routing. So what is it? So, and I think they already beat me to it at the tech docs. They already put a definition. But really, routing is just the physical connection between your objects on your board. So you've got, typically with metal, but I think of routing of anything like a polygon pore, a track, anything that connects your electrical objects that have the same connectivity. So the connectivity and connection lines, so what are they? Usually when you pull in your board, you get something like this, full of what they call rat's nests or connection lines. So the connection, so any electrical objects that have the same electrical net or have the same net, they need to be connected. Because at the schematic, you just wire things up. Things can be logically connected. At the PCB, everything is pretty much logically connected, meaning there's no physical connection between different paths. So you have to connect them with a route. So starting out the pieces, of course, you have your layer stack, board size and shape, the number of routing layers, your design rules. All these kind of tailor to how you're going to approach your board and route your board. And these have, a lot of times, if you're working on different projects, these will change quite, it'll be changed quite drastically. Or if you have a large, big chip, you'll need more layers to accommodate the extra routing. And that's where, going back to the fabrication notes, typically they'll say, these are the required number of layers. Of course, there's different tricks and tips to reduce the number of layers, different, I think we've got Happy Holden here talking about HDI technology, getting as chips get bigger and more pads, there's different types of routing styles and be applied. So now the stack up, of course it's changed a bit since if you're familiar with the older 8017 to 18, and even in 19 they've changed the stack up quite a bit. And of course here's where you add your layers, you have signal layers and plane layers. And we won't really get into the difference of that. It's just that if you have a signal layers are for routing layers. If you have a power layer, it's just solid copper. It's a negative layer, so you can't do any routing on those layers. One thing you can consider is using a signal layer and flooding it with copper. So then that way you get an extra routing layer. But otherwise, if you just have a power layer, and I'll show you how that looks a little bit. Now, a new thing that they've added in 8019 is with partnering with Symbian, built into the layer stack is the impedance calculator. Now, in earlier versions of the tool, you'd put in an equation, and at one point they got voted in an equation. I don't know where it came from. I think it was for probably a specific process, but it wasn't. It was different from the classical. So now in 8019. You just click the plus up here at the top, and that will give an impedance profile. And basically, so like here for the top layer, there's nothing above it. That's why there's no top reference. And then for the bottom reference, it'll have the plane underneath there, and it uses a solver to give you impedance. But in order to get your impedance set up right, you have to make sure that you stack up all of the heights and match exactly what your fabricator is going to do. So a lot of times, rather than try, because you can use other tools like to calculate your stack up thicknesses, but this is a good point where you talk directly with your fabricator, and a lot of times they'll give you for your impedance requirements, they'll give you the thicknesses required on each of those stacks or the layers. I think this one, I'm not sure. It's a pretty advanced simulator. If you look at their website, and they do full 3D analysis, and some of their videos is pretty incredible. So I think this is really exciting having this in here, and I think it's a full 3D solver, but I don't know if the stack here is using just a 2D solver or capability, but it's got. If you look at some of I think it's Yuri. There's some videos of the full 3D spectrum with things pulsing, and they show the return path. It's pretty amazing. So then, and you can add multiple impedance profiles here. So then, when you go into your width rules to set up your impedance, you choose that impedance profile in the rules. But then you can also override the values in the rules as well, and I could show you how to do that. Now, setting up your vias, there's a new tab called via types. So you want to set up your vias, and these are the allowed via ranges when you're routing. So of course, there's always going to be your default through hole. There's no getting rid of that. So then you have your blind and buried micro via. And so when you create a via, you click the plus up at the top, and you'll have a properties panel. And so the properties panel is where you define your the via style. If you have a symmetrical stack, you click the mirror option, it'll create the via on the top and the bottom. But your stack up has to be symmetrical. Otherwise, If it's not symmetrical, it'll say, okay, do you want to, it'll ask you how you want to apply the stack up, and it'll help you make it symmetrical. But
are you setting all of these via types up prior to even starting the design?
yeah, you want to set these up before the design. Now, if you're using a template, I think there's a really good talk on using templates. You can bring in a board that has all of your vias already placed on it. A lot of designers like to do that. There's also a pad via template library. And with pad via template library, you can pull in your via. Basically it's the you're really just pulling in the size in the via template library. It's just the size and dimension of the vias. But in here, for the range, that's why if you have your vias already on the board and it's this stack up setup, you can import your layer stack as well that has the vias set up in them. And oh yeah, and so you've got, oh yeah, so that's going the wrong way. Yeah, yeah, yeah. So then
that is the outside.
Yeah, of course, yeah. So with the laser via or it'll that's where they have the little conical shape. Now, setting for microvias in your rules, one thing. There's a couple different discussions in the forums before you specify a drill pair. You can set the starting and stopping layers. Now, in your design rules for your routing via style, that'll be the size of the via that you want to target. So one thing. So there's a query is microvia. So you can target a specific microvia, or for the setting up your via style, you can set the starting and stopping layers for. And then you can set the corresponding via diameters and hole size. Now, I don't know if I talk about the now because I know the design rules a little bit later. When you are in here, and I might talk about this a little later. When you're in this section, you want to you can either use min max preferred here, or you can use a template. So now the template, whenever you place the template into your board, it creates a template value that automatically based on IPC naming. But so if you use templates, this will then you specify the template that has the via diameter and hole size. Otherwise, you can have this min max preferred, which then you set the minimum, the maximum preferred sizes of the via. So if you don't have your templates, if you have a brand new board, you won't have any templates in here, so you won't be able to set them up. And maybe I'll show a little example of that later. And of course, the other features in your stack up, over here you can set your, of course, print electronics, rigid flex, and your back drills. So if you're using high speed and you want to set up your back drills, you need to enable back drills here. It pulls up another section that you can define your back drill values, and then there's a corresponding design rule that you specify the maximum stub that's allowable, and any other stubs will get back drilled out.
I have a question.
Yes.
Is the main advantage of using via stacks versus the min max?
It's just they're more predefined, so
Does
yep.
that limit you from using something outside of those, so you end up with fewer drill sizes? Is that the main advantage?
Yeah, and it's more predefined. So it's this you just grab your, and it's defined. So the way that the way that it's done, it's named on the via size, the diameter, and the hole. So you know exactly what you're using, and you just switch between, instead of switching between like minimum, max, and preferred, you can just choose the template. So it's now I don't recall offhand. We can take a look if it lets you swap because when you're routing and you hit the 3 key, you can cycle between the via sizes if you're using min, max, and preferred. I think with the template, it allows you to cycle between templates. So you would define each specific size in the templates versus a range. Of course, some of the other commands in here. Well, when you're routing, I think interactive routing, it's UT. If for some of your older school, it's P, press the P plus T. But you have your so interactive routing, also Control W, which. So you have your interactive differential pair routing and multi-routing. Active route, I might just touch on just a bit, but it's tiny. It's very lightly. Then there's gloss and retrace. So now with gloss, it allows you to select a routed trace. Of course, there's always during your route, there's always some amount of glossing, and you can change the glossing strength from either minimum, no glossing at all, turn it off, versus there's a medium gloss and then strong gloss. And this is really how it will flatten out the line. So as you're routing, if you have little jogs and a little, you've added accordions and things, and you move the track. If you have a strong gloss, and I'll show you a little example of that later. It'll smooth the line out a little bit. Yes.
When you so glossing, I use the auto route sometimes, and I do cleanup.
Yeah, the cleanup. Yeah. So the auto router is the cleanup just goes through and tries to just reroute the trace. Now the glossing is it's kind of actively when you're dragging traces or in a routing, it will try to clean up all the little extra segments, and if there's little jogs, it'll smooth out the track. So it's not.
So the more you have it turned on, the better chance you got to get rid of those extra segments.
Yeah, and especially if you have a fanned out component and you're moving your vias around, you can also, and I'll show you how to change the gloss cycle. Now, one of the keys is this Control Alt. So a lot of times when you're routing and you're going into a pad, if you just click outside the pad and hit Control Alt, it'll turn off glossing temporarily. So I found, because a lot of times I'll see designers just turning gloss on and off, and so you can use this temporary key for disabling gloss.
That's while you're actually running the segment, and you do Control Alt.
Yeah. And now also when you're dragging, you can disable the glossing. Now in 8020 that's coming out, they've added some extra information in the properties panel for your drag, which makes it really useful, which we've never had that before. So it's once you get into the final, I always think about PCB design as kind of a chess game. You have your opening, which is your component placement. You might have your floor planning. And really, placement is the key of your component placement. If you don't get your components placed properly, you might down the road it's a lot easier. You have to go back and move your components around for. Oh, sorry. So retrace. Now retrace is a really nice function because if you change your width value or in your clearance, retrace, you can select the tracks and apply a retrace, which will then apply the new rule. So it might give a little extra move the tracks so that it's following the new width or the new clearance. So rather than trying to just manually route them out, one way to select the route is you just click on it and hit your tab key, and then that'll select the entire length of the track, and you can cycle through with the tab key, and I'll show you an example of that.
So retrace use that. You decide how you can change it.
Yeah. Right. So you just click on the track, hit your tab, precisely. Yeah. No, we'll retrace it. So that'll be a command. So, and gloss is always on. Yes, but you can cycle it here. Control Alt G, and now with the new properties panel, when you're routing, and hit Tab, it pauses it, but it also brings the properties panel into focus. Then you just unpause it, and then it'll show you all of your settings. So, and I'll show you how you can keep track of that when you're in a little bit here. Of course, now Fanout. Now Fanout still invokes our auto router, and I know he brought up the auto router. We do have auto router, but it's not really. They haven't really done a lot of work on it. I don't know what the focus is. On smaller boards, it can do good, but if you put anything like a Vertex board or anything like that, it'll route for 6 hours, and it's still you're not anywhere closer than if you would have spent 6 hours manually. So now, but the Fanout, you have all power planes and signal nets. I'm not sure how they're going to R&D is going to address power nets. Because now that they're getting signal planes with polygon pores, so they're thinking about different ways, like maybe a mixed or something, so that way. And typically when you fan out your power planes, it fans out all of your surface mount pads that are associated with a power plane net. And of course, power planes are special layers, but they don't allow routing. So it's kind of one of those catch-22s. Yes?
Yeah, sometimes when I'm running doing a fan out, nothing happens.
Ah.
There's no indication as to why.
Right. Now I'll show a real quick example if we can get, because a lot of times if there's stuff underneath there, it just, it just doesn't, yeah, and it'll just stop and you'll say, what happened? Yeah, so you can fan out all, now if you hit fan out a component is usually the typical one you want, and I'll talk quickly in the demo on how to check what fan out is applying to your component. You can also fan out a pad. If you have a room defined, you can fan out the room as well. So of course, auto router, I'll skip over that. You can try at your own risk. On smaller boards, it's kind of nice, but the auto router always does funny stuff, and requires a bit of cleanup. So I had the auto router the auto router challenge to see who could route the board faster. On smaller boards, it gives you advantage, but once you get anything like any type of BGA on there, that's where it degrades. So the other commands, now there's unroute commands. You can unroute a connection. We click on the connection to unroute that. There's now some special delete commands. There's a select physically connected and select, sorry, I'm getting the cameraman, make him work back there. And there's select physically connected and select physically connected on a single layer. And so what that'll do, you click on the track, it'll select the whole track and then just let you hit the delete key. And if there's vias, it'll go through to the other layers, so you want to make sure that select physically connected on a single layer. It'll just select all of the track between your pads, and then you just hit your delete key and that's gone. Now one of my favorites is control delete, where you just click on a segment within your routed track, hit control delete, it'll delete that segment, and then it'll highlight the ends on each side, and it'll sort of unwind your track from, just hold down control again, hit delete, it'll delete those two segments and select the next adjacent one. So if you have to start in the middle, start control and deleting, unwind it, then you can reroute. Of course, as I mentioned earlier, the tab is to extend your selection. And so settings, controls, snapping, and layers. So I wanted to spend a little bit of time looking at the snap controls. There's been a lot of discussion recently in the forums about snapping, especially when in 18 and 19 they've added extra snap controls. It's helpful, but right now there's a lot of it's almost like driving one of those cars where you have to go and tinker a lot. It's like every time you route, it's like tinkering under the hood. So
one of the things I've noticed with 19 is I have to exit what I've got selected to go work in the properties panel to get to the snap menu.
Yeah, let me show you.
Is there a way to,
yeah, I'll come right back to that. It's really cool with the snaps. So they've been trying to make it easier, and so I know that. So I'll show you how to do that. Of course, the interactive routing preferences are here under PCB editor. You have your interactive routing. Now, a lot of these are synonymous with the properties panel. So when you're routing and you make changes in the properties panel, it will update these settings here. And in the properties panel, it has shortcuts. So you've got, now up here at the top for the routing conflict resolution, now when you're routing, now how does your route interact with other objects? Is it going to hug, push, wrap around, stop? And and you cycle through that using the Shift-R key. And every checkbox that's enabled, that's the one that it'll cycle through all of those. So if you don't want to have to click your Shift-R 6 times again, you just come in, uncheck the ones that you don't use. So if you're only using walk around and maybe push, uncheck the rest, and you just Shift-R. It'll just cycle between those two routing avoid obstacle modes. And then of course the current mode that you're in, and that's cycled with Shift-R. So dragging, now dragging's here because when you drag a track, it's really a kind of a subset of the routing function. And so the dragging, you have a preserve angle. So if you have tracks at an angle and you drag those around, then it'll preserve the angle between those. And I'll show you a little example of how you can select a group of bus routed tracks, and you can slide them over, and it'll keep them all together. Of course, now they have this selected or unselected here, which I'm a little mixed on that. I usually set them both to drag, so as you're moving things around. Now historically, Altium has always been just a click and move. You just click it and move it, and you can then also, used to be able to just hit control and it would drag it. Now they've changed the behavior, so versus whether it's selected or not selected, when you move the object, it'll either just move it or it'll drag it. So I found that I like to set them both to drag, but you can play with that. Because a lot of times you'll be selecting things and then not selecting them. So if you just, and usually it's at the end, and you might change it at the beginning of your design versus the end, because it's always the end game when you're trying to slide all your tracks around to make those last few connections. So, so you've got the selected versus unselected. Of course, component, you've got your component dragging is in here too. They just threw that in there. So you've got, as you're moving components around, move components. But they've added this new component reroute, which if you have routing, now before historically you'd have to do a move drag command and it would just rubber band all of your track connections over. It was really ugly. So now you're working on this. So with component reroute, when that's done and you move your component, all the routing tries to move over and reroute itself. And so sometimes you forget and you'll move this big chip over and you're thinking, what's going on? So it's just one of those things. If you're using component reroute enabled, you can cycle that using the Shift R at the board. Because if you don't want to move especially big component or a lot of tracks, because it will try to reroute it when it's on. It'll give a little indicator if component reroute is on or not down at the bottom.
Now, we are going to get a copy of this.
Oh, yeah.
Emailed to us.
Yes, yes.
After the comments.
Yes, and I have put all kind of animation in here, and then I've remembered from last year, so I flattened it out. So I tried to make it as easy as. Now component movement with routing, which is new that they added in 19. So if you have different routing on there and like fanouts, when you're moving a component with relative routing, it'll move the routing along with it. You use your Shift Tab if you don't want to. It'll kind of cycle through what moves along with the component. So you just hit Shift Tab. If you're not using this, you can still move the component with the relative routing by hitting just Tab. So you hit the component, you hit the tab, and whatever gets selected when you move that component, then it'll move those along with it. So of course, then the other preferences, of course, by pressing the Tab key, and you've got a lot. So you've got your Rouse glossing effort, whether you're removing loops or antennas or not, and it's always going to change to be like, especially with these remove loops. So you can go in and edit the net itself and say, don't remove loops on these, because I've gone through a board and all of a sudden I've noticed these little holes over in my polygon pour, and I'm saying, what happened? Unless you have auto polygon pour on, and I like to keep it off and you say, where do these holes come from? And you realize that you made a connection and it removed a loop and removed your vias. So you just got to be careful with loop removal.
Activity turn off for the power and ground. That's enough, like
Yep.
lots of destinations because I
Oh,
don't know
right,
what's
right.
getting removed.
Yeah, so like powers and grounds, and you can even go into the nets themselves and edit the net, and there's an option to disable loop removal. But otherwise, also via pushing, you can turn that on and off, especially when you're routing underneath a BGA or something where there's a lot of vias. I like to, when there's things that you can lock routing down to, just select the routing, hit the Tab key, and then click the lock key in your preference panel. And so then you can set your track width modes up here, and then you can cycle those through the preferences. So we'll see that in a second. Of course, then at the board level, so when you hit the Tab key during a route, it brings up the properties panel with relative information to your route. So I always like to, even if I'm not changing things, I will hit the Tab key to bring up the properties panel, just so I can see the settings, and then I'll just hit the escape key or hit the pause, and just so I'm back to routing. Of course, you've got your net information, you have your layer via template, the min max preferred, and so it's got a good information. The gloss effort. Now this is where I had to change it back up because I realized I had been working in 80/20, and now when you get into, if you move to 80/20, they've been working on a new, more of a any angle type routing, and it's more, it kind of ties into like through the snake routing. which allows you, now they have these new corner, this new hugging style. So which they'll be, and they've added it. And this might change, it's still early alpha, so I was kind of cautious about going to throw it in there. So they have a new rounded, where it'll try to do a tangential hugging around certain objects and get more of any angle. Or you have your standard, the older method, and so a mixed. When they first came out, you had to go in and tweak different preferences. Now they've got, so that's something new that's coming. But then you have your routing gloss effort, so you can cycle through that. So as I mentioned earlier, I think it's, and I've read a couple different, I always get confused in the routing of gloss effort because it's control. And so, but then, you can also click just before you go into the pad and then hold the key down and go in. And I'll also show you with the snapping once you enter in a pad as well when you're routing. Then of course just other rules that are that you can choose, they can display. Now the display clearance boundaries, if you're not using those, they're really very useful sometimes because that just shows the unroutable area. It puts a border around everything, and once we get to the demo, I'll show you. So when you press tab during routing, I didn't update this one, still the 80/20 one, but it's just mainly you have the new hugging style. So in 8019 and earlier, we don't have this. So I always felt like when you get to this point, when you're sliding your tracks around, it's almost like getting in a street fight with Altium. So, and you're not really, because you're dragging things around. So now when 80/20 comes out, they'll have the dragging, when you drag a track, will now have information in the properties panel, what we've been, so that's going to really, really help once that information is available. And so, and also again, you have your gloss mode. Now you have so they have the change gloss mode, Shift Control G. Well, I'm not sure if that works in 19 or not. Which so you can still change your gloss mode, and it shows but it has the information up in the panel. It's really important to limit the amount of layers that you want. Of course, hitting the little eyeball next to the layer will turn it on and off. So this when you press L will bring up your view configuration. You can hit the eyes next to what you want. There's some pre-built-in layer sets you can use. Now down here at the bottom, you can create your own layer set if you want so then that way you can quickly turn on and off layers. And it ties into snapping a little bit later on, because whatever layers you have enabled, if you have snapping on all layers, it will use all layers. So you might be trying to get something up on, you route something on the top, and it's snapping something down on your mechanical. And I'll show you the snapping in a second. So then down you click LS, and you can turn on and off different layers. If you've defined your own layer sets, will be here at the top.
So if I did custom layer sets that I have visibility, it would show up in that.
It'll pop right up here. Then you can click on it, and so because a lot of times I found when I first started working to Altium Designer, they didn't have that. All day long you have to press the L key, bring them up, turn them off, and back, and then so this is really big time saver.
Been a feature for.
Oh yeah, it's been around, but it's it's kind of hidden, and especially going to 18, they kind of buried it. They almost took it away, setting some of the configurations and things. Now you can export it and you can save it, and so it's back. Now Control D, it's just bringing up the view options, and this is really important to come in here where you set up your draft and your transparency modes. So you can hit the Control D, or when you're in your layer sets, you just go and click on the view configuration at the top. And so in here, of course, now I don't recommend hiding electrical objects. I see a lot of designers who will just hide their polygons, which is a bad idea, because they still are there, you just don't see them. So then when you're trying to figure out why is my route not working, it's because you've hidden the polygons. So it's better to, I like to set my pads and vias in draft mode, because a lot of times when you underneath in the middle of the pad, it might be snapping to the center of the pad. And so this way it gives you X-ray vision inside of the pad. And polygons and tracks, I'll set those to the transparency on those. And you can set up the transparency for a lot of these. Now they're bringing back the specific layer transparency. So I know a lot of you were missing that, so that's coming back. We're that way on individual layers, because right now these applies to all layers. So of course you have hide for transparency. If you slide it to the left, it's brighter. To the right, it's darker. Then down under, you've got your advanced down here on the bottom, which I think that'll bring up the all of the individual layers. So for example, here's with the draft transparency off, and now setting the tracks and paths and vias to draft and the polygon to transparent mode. You can see here I have a track that's underneath there. You can see the routing of that under the polygon. And it's really helpful, especially with your tracks if you have them transparent. If you have little segments, you'll see a little circle in here, and it's really helpful to try to drag those slightly to clean them up. Otherwise, later on when you're moving things around and pushing, it can cause little funny things to happen. So it's a good idea to take the time, look at it, make sure you just click on a segment, drag a little bit, and make sure everything is nice. With glossing, it automatically optimizes. So if you have a little circle in here, you just click it and just move it a little bit, and you'll see the track will turn into a solid line. Of course, 3D view of copper. Now this is because a lot of times you can, when you're routing, you get a visual in the board, but you want to see, and it takes a while to export out to Gerbers, but you can kind of get a visual of what it's going to look like right at the board. So now this Control-Alt-3, we all know 2 and 3 takes you between 2D and 3D modes. Now Control-Alt-3 will take your current 2D view and push it right to 3D. So you'll have the same view because 2D and 3D have their own zoom areas. So you just use Control-Alt-3 will take your current zoom, and so I have that same, it'll take you right into that same location. And same thing in 3D, you find a spot, Control-Alt-2 will keep that 3D aspect and pull you into 2D. So here, so Control-Alt-3, that takes me into the same spot, and I was in 2D. Shift-S gets into single layer mode, then you choose the layer that you're interested in. If you have component bodies and other things like that are in the way, just hit Shift-Z, that hides your components. So this way you can get a kind of clear idea of what it looks like.
The Shift-Z hides all the components?
Yeah, that just hides the 3D bodies, so you just turn them on. You turn them on.
Okay.
And that's just for visibility here.
Got it.
Now also masking and dimming, if you control-click on a pad, it'll dim all of your PCB except for that particular track, and you can use your left and right brackets to increase and decrease the intensity. And down at, so you also have some different settings for pad nets, pad numbers. The via span, you can see the range of the via that the via goes through can be helpful, especially when you're using stacked microvias. And you'll see that the range will automatically change. So if you drop a via from like layer 1 to 2, that's a microvia, and then it'll show 1 to 2 of the range. And if you drop a via right down on there again, then it'll automatically change 1 to 3, although it's 2 stacked microvias. Of course, F5 net color override, which I like that quite a bit. Now, when you take a look at this list, there's a ton of commands. So now, if you just remember this one item here, which is the accent grave. So when you click on that, during an active command like a route, it'll bring up the whole list of all the options. It'll show you what's enabled, the shortcut. So then that way, so of course the commit, left click, or enter. A lot of times what you'll do is, if you're jumping to a location, you're routing and hit jump location, you'll just hit the enter key, because if you move your mouse, of course, there's a chance that you'll move it slightly. So if you have an exact point you're going to route to, you just, as you're routing, you just hit JL for jump location. You put in the location, you hit enter once, it jumps the route to that location. You hit enter again, and it'll commit it. Of course, you have your undo is the backspace. So whenever you click, that commits a portion on your route. Just hit your backspace key, it undoes the last route. And of course, pause or tab brings up the mode. Then you have the other modes that are available here. I just wanted to talk a moment about look-ahead mode. Is that, especially for newer designers, look-ahead, it's where when you start a route out, it's outlined it there, it's where the last segment is hollow. And so when you click to commit, it's only the hatched area will be committed. The hollow area is not. It's just kind of so you can align your track up. So as you're routing out, so but sometimes that means if you want this whole thing out there, you have to click twice. And that's because you have look ahead mode. You just hit the one key, then you click once, and then that will commit the entire track. Now I had a shout out to Chad Sathoff. I probably got his name wrong because he had a forum question the other day, and as he said, when I'm routing and I hit the 2 key to drop a via, my via is not following where I want to put it. It's like what happened? It used to work when you have this follow mode on. The via sticks right here at the hatched area, so it doesn't go at the end of the look ahead mode. So once you hit 1 to go, get out of look ahead mode, the via pops right onto the end. Of course, you cycle track width. You just hit your 3 key. If your width has a minimum max preferred, you can cycle through the width sizes. Also via size source, you can cycle through those with the 4 key. And now switch layer for current trace. Control or by when you hit the select layer L, the arrow should be up one more. L only works if you're routing right off of a through hole or a via. It'll switch the layer. But this Control L. So when you're routing, Control L will bring up a list of layers that you can jump to, and you choose the layer that you want, and it'll drop it, and it'll try to select the appropriate via for that range. But they have the 6 and 8. So select routing transition. That allows you to choose, if you have several different drill pairs, this allows you to choose the drill pair that you want to use. So if it's like one, top to bottom, or if it's blind or buried, you can cycle that using the 8 key. And selecting 6, the 8 key brings a little pop-up. 6 will let you cycle through the available drill pair ranges. Now the snap control. So in the properties panel, you have snaps for grids, guides, and axes. You can turn them off here, and I'll show you the snap pop-up that they've added that makes our lives easy in some ways and more difficult in others. But so you've got the snap options. What are you going to snap to? And then you have the snapping layers. What layers are you going to snap to those objects on? So it's kind of two different modes going on there. Now the snapping layers you can control with Shift E. So, and it'll show either hotspots or hotspot all layer or off. So you can turn, and there's a temporary override for this. I think, so I hit Control. Control is the temporary override for the snapping here. And of course you want, if all layers is on, it'll use all of your enabled layers. And I believe, I don't know if this statement is completely true, but I think even in single layer mode, but I might be mistaken. So if you're coming into routing into a pad and your track always snaps over, just hold your control key. That'll temporarily override the electrical grid and allow you to route in without. I used to always have to cycle through Shift E a lot. Now you just have to hold your control key. It's a lot easier. So the control to override, and then your objects are snapping. If you were used to 18 going to 19, they've moved near and far objects into 1. So this is what you're going to route. And on the forums, this is causing a lot of difficulty for users as what to snap to, because there's a lot of configuration here. So you've got track arc vertices where your track and your vertice meets. Track arc lines, that's the entire length of the track down the center. Now, so see, I've turned everything off at pad and via centers. So that way, for the electrical hotspot, it won't look at anything else. It just allows me to snap right to the center of those pads.
So how do I get to this while I'm running?
Yeah, I'll come to that just a second. So now, and also the snap distance. Now, since they took away the near and far range, it's set to 1,000. If you have the axis snapping, which allows you to line up to different items, so I always recommend put something smaller in here, like 200 or 300. Otherwise, you get these lines trying to line up to everything on your whole board. It can be really, really difficult. So you have the axis snap range. So when you have your snap override indicator, once you get into electrical range, you get this little indicator here, and that shows that you're overriding your snap grid with the electrical snap. So even if the grid is right on, if the hotspot is on a grid, you'll still get this little indicator. So you have a snap override indicator. And so these axis snapping, so with any object that's enabled for snapping, when you have the axis on, you get these little beams. So that way it's aligning itself with the different objects as it comes into the X and Y plane with those.
Is the snap override like ignore like Fanout rules and stuff, or is it?
Yeah, it's the interaction with your cursor with the items on your board. So now there's two ways to control the snap. They have this little magnet up in your active bar if you're using active bar, and Control E will bring it up during your active command. So as you're routing, just hit Control E. It brings up this little panel here, and you've got your grids, guides, and axes up here at the top, and then you have the objects that you're going to be snapping to. And so right now there's just 3 modes. There's all on, or all off, or custom. And custom is when you've made a modification, and if you go from your custom to all on and then click back to custom, it remembers your previous settings. It's just that, but a lot of times, depending on what you're routing, you have to come in here a lot. So you hit Control E, turn it on. Like a lot of times, like if you have like intersections, that's any intersection. You see, you even have pad edges and things. So there's just a lot of stuff to snap to. So when you're trying to route and do a decent route, you want to make sure you come in here, hit Control E. Try turning everything off except like pad and via centers if you're routing to help if you're just snapping to too many things. And some really good ideas on the forums. Hopefully this will kind of evolve to make your snapping cycling easier. But right now you just have the three options. Of course, lastly is the PCB panel where it's broken down where you have your routed. At the very top with nets, it shows you have your net classes and nets. And I want to talk a little bit about the signal length and pin versus routed length. Because with signal length, if you just have 2 pads, it automatically calculates, kind of based on a new calculation method, the routed length of your trace. But once you get a third pad in there, you'll get a little NA. It can't calculate it, and then it'll use the routed length, and that can affect your length matching rules. And then that's where you get into XSignals, where if you have more than 2 pads, you can create an XSignal that can go across multiple pads, even across components, and that'll calculate the signal length. And versus signal length is where it doesn't look at overlaps if it goes through and I'll show a little example of that in a moment. Of course, net color override, you can choose, you can set net colors and override it, so then that way you can get a clear visual of overrides your layer color to get an idea, especially when you're placing your coupling caps and others, that you can see pretty easily where things go. And then XSignals, where if you define your XSignals, it's useful for more complicated link tuning. Of course, differential pairs, you can typically assign them at the schematic level, but you've got your differential pairs. It'll show the length of them here as well. Via stitching and shielding, when you create via stitching or shielding or even interactive link tuning, it creates a smart union, and you get those will show up here in the list from the PCB panel and the unions. So just quickly look at design rules. Let's see how we're doing on time. It's okay. So 9. Okay. So there's some really good technical documentation if you go to our tech doc site, which of course they call it. There's the routing. There's another one. I didn't put the link here. It's called I think it's where they talk about editing the routing, and they talk about differential pair routing. So this gets into a little bit deeper discussion than what we're talking about here with a lot of good illustrations. All right, so I guess that brings us over to the demo. I try to get through those fast because usually I like to extend things quite a bit. So let's go ahead and get Altium Designer up here.
Is the latest version of Nexus also includes Altium Designer 19?
Yeah. So Yeah, so if you're using Nexus, now Altium Designer 18 and Nexus 1 are pretty much synonymous. So actually, so right now with Altium Designer 19, we have Nexus 2. And so the next rendition will be with Altium Designer 20 coming out, we'll have Nexus 3. And under the hood, they're the same. Of course, Nexus is tailored a little bit more for working with your online. You can't even run, so it gives you more restrictions than a larger corporation. All right, so let's go in over here. So on this one, let's just go now the PCB panel. So here I just have a board. It's got some unrouting on it. And so in the PCB panel, see at the top, I have my nets. And if I click on power, now you can assign your net colors at the schematic level. See, so here, and if you have, see, right now ground is hidden, so it's not showing. But if I click on ground over here to override it, I think I need to turn on my F5 key. Yeah. So here I can just with net color override, I can see where all my ground pins are. You can change different colors. One quick way to assign, of course, those can be assigned at the schematic level, and they are they synchronize with your PCB.
Is there a way to set the no-net for color?
Well, the no net is just the default. These default nets. You can, and if you assign that net color before you bring before you import your PCB, then it'll get assigned to that no net color. But, and there's some ways the colors in the preferences you can go in. You can assign the no net colors or all the colors in there, and it's just called connections. They changed the name a couple of times, and I think there's a new discussion on that. But a lot of times if you it assigns the default on the import, and there's a recent discussion on the forums about changing that. So if I hold my Alt key and grab around these here, so if I click on all nets here, and I'll make sure select is on, and over here if I hold, and this is a technique they use for active route where you hold your Alt key and right to left drag where you get that green around your nets. But if I'm in here and I hit my Tab key, then it selects those corresponding nets in the list here. So I can right-click over here and change my connection color and put it something that just to show you, because these are so I can. But I probably should have made them a little bit. Those are more yellow, and so if I hit the override now, I had one funny forum post in there. He said, "Why did my PCB have measles?" And it's if you do have a color override and you check the box, when you're zoomed in, you get these checkered boxes on there, and when you zoom out, it turns solid. So of course, I wanted to show multi-routing, because a lot of times on a chip like this, a lot of times what you want to do is you want to route all your connections up around it. And this one, they didn't fan out the outer two rows, so they can use that mostly for pin swapping. So you want to route all of your tracks close to it, then you run a pin optimization on that, and then you can transfer that back to the pin swapping, and you can transfer that back to your schematic. It's just that there's really, at the schematic, you have to have your connections logically connected. You have you can't hardwire them in the schematic. You break the wire and you use two net connections to wire them up. And so that way, when you push your changes back, it'll swap those nets around, so to match the PCB. Same thing in the PCB. You can't do a pin swapping if it is hard routed. So that's why you might see this thing called the subnet jumper, which what they do is when you're out up here, you can add a little gap in there and then add subnet jumpers, and it just puts a little jumper in there to close the gap. And then if you need to pin swap later on, you remove those subnet jumpers and so then that way it removes those little gaps in there, and so then so that's where when you see in the route menu there's these add subnet jumpers and remove them, and that just ties in with your pen swapping. So now if you hold, there's a select. If I do a select, there's a touching line. Now to select like pads, I have to hold my control key down. So just hit control, and I can then click over here. And you want to make sure you hold your control key before you click to touch your pads. You can also drag around there, or you can shift click on each one. If you accidentally get one click selected, just shift click on it. If you have your pads selected, this can go to U. I could press the U key. Used to be P, but they changed it now to the wherever you have an accelerator key up in the menus, like a route, the U's underline, you could just press U. That'll pop up the menu right on your keypad. And there's interactive multi-routing. Now sometimes if you're going to do interactive multi-routing, it's good to come out with a little stub. Sometimes when you're moving these around, what will happen is they'll kind of finger in and try to kind of close in on each other. If you click it when it's kind of wrapped around, they're not going anywhere. So you want to make sure if you kind of extend it out a bit. So I'll just come over here around the corner, and I'll hit the B key to see how they're kind of. When I hit B to bring them down in, and if I kind of push them over out of the way so they have enough room to unwind. So I can come over here, and these will walk around obstacles and things. It's not the most intelligent, but it helps. Let me hit the backspace key on that. And of course, in your routing, Murphy's law of routing is the elbow always goes the opposite way, so you hit your space bar. All right, so just pop up here, and see sometimes it does little ugly things in here like that, and you can always just grab and try to push these around to clean them up. Now with the when you're dragging the preserve angle, you can do the same thing, select and then touching line, and just drag around here. And if you move these, it'll slide all these. Sometimes you can, versus trying to grab one of these and push it, you can just grab the section and slide them. So of course this one, you want to make sure, as you're pushing these tracks around. So you can also grab a corner over here and just drag that down. It's just when you're trying. Now see down under here, see when you're down at the bottom, if you look where it's coming out of those tracks, how it's, this down here, it's because of the glossing mode. It's kind of glossing. I think, now I've been getting it mixed up with the buttons I'll try, so I think it's like Control-Alt. Oh, no, it's Control-Alt I'm doing this, so we'll do Shift, Control, okay, Control-Shift. Okay, yeah, so Control, because in the document, there's Control-Alt, I think when you're, but it also mentions Control-Shift. So I'm not sure if it's our document, I was a little confused on that, but see, so right now when I'm coming down here, see it's kind of getting, if I hold Control, it's still kind of doing it, but it's, see now this, I'm holding Control-Shift down, and it's temporarily disabling that, that glossing. So sometimes when you're dragging, it gets a life of its own, and things will finger around because of the gloss. You can also cycle the gloss, Control-Alt-G. So if I hold my Control, actually it's, yeah, Control-Alt. Maybe it is Control-Alt. So then that way you can get things moving without them. See, let me just hit Control-Alt down here. Yep, Control-Alt's not doing it. Shift. So you want to get these, because now with this board, they have these coming up, routing up and around, and then they have these coming down underneath, so you want to get enough room. Now you can also drag these like across. Sometimes, depending on your shift mode, see if I'm in, there's ignore mode, hug around. Sometimes you just have to grab it and drag fast and to get it to go across, and then you just can grab these. I'll hit Control D. Control D, if you're in the board level, it brings up the view configuration to your view options. And what's nice is, now if you went from 17 to 18, they initially lost your view configurations, which, I was kind of devastated. They said, oh, we don't need them. It's like, oh, sorry. but there's a way that you can, now these view configurations control all of these settings. So rather than coming in for every single board and setting them up, so if I come here, click my pads and vias, I'll slide my tracks. That might be a little too much. My tracks and my polygons. And you can get all of your settings set up in here, and they've got a, see when you make a modification, it says custom configuration, and that's just local for your current PCB. But if you click the plus now, this comes in with a real configuration that will save your settings. So then I can change this to be like mytran. And so there are also some and then you hit the save key. There's some predefined transparencies. So if you go to the Altium Transparent 2D, it has some pre-settings that'll automatically get set up. But then if you've saved your own, you can then grab that. And I'll show you that. See, I just saved it right now. So I'll show you when I go to another PCB, I'll have that same configuration. I just can choose it, and it'll apply my favorite settings. So these, if you get little jogs on there. And this way, I like the tracks and transparent mode. So if there's like this has little, you can get these, see where these little segments are, and that way when you move them around, you can optimize the track. You just drag a little bit, and you'll see the track will turn into a continuous segment.
I've had that happen, and I have a hard time selecting that little segment.
Oh, yeah. Sometimes you could just optimize it out by just dragging a little bit. Also, there's the if you do the left to right drag, you get the blue box, and that'll select things in there. So even if I'm over here, even at the board level, you can still access your snap. Just hit Control E, and that'll just pop up the snap options. You can just hit if I click all off and then do track. These are the snap. Sorry, that's the snapping. You have to click the little filter up at the top. So at the filter, you have the same thing. All objects I can turn, and these are the objects that'll be selected. So this is your selection filter. So you click the filter. I can click all off and just choose tracks. And so now, when I come over here, I can then left to right drag where I get the blue box, and it's only going to select tracks. And same thing over here. Sometimes when you're trying to get rid of your fan out and things are here, you can drag around here. Set it to only vias and tracks. One thing is when you are unrouting, if I unroute, the unroute does not remove no net fanouts. So I know there's some discussions I've been reading about, fanning out everything, even no net, just so. But if you do fan out your no net objects and you unroute it, they'll still be there. So there's a filter that you can use. Let's go to the PCB filter. And I already typed it in here, but it's. I thought I put that into the slides, but maybe I didn't. But it's got the. And you can use parentheses to kind of target these. So it's is track or is via or is arc in case you have arcs, and on signal because you don't want to drag around, grab everything on your mechanical layers. Then so net equals no net and not in any component. So if I was to apply to that, see I've got this little no net. Actually, I don't think I've got any in there, but if I had, let me just start routing here. UT. So if I route anything without a net on it, see now when I click that, it's going to apply it. I had select on there before, and so this way I could, or if you don't select it, you could just apply a filter, and then you can. And this way, if I had all objects, when you apply a filter, there's you can either mask it or dim it. Now masking says don't select any other objects. So when you drag around, it's only those targeted objects. Or dimming says it's just going to dim the intensity, but you can still select other objects. So it's just one thing to keep in mind when you unroute, when you found out your component with no nets, when you unroute it, getting rid of them, you're probably going to have to write a special filter to select and delete those. Okay, now in here, so now I'll spend 10 seconds on active route because I know you guys probably some of you guys don't want to know about that, but it's a good tool. It's there. It's useful. It's really for more or less digital or good layout. It doesn't really work for RF or analog as well. But if you have digital memory or other chips. Now, active route doesn't add vias, so you have to do your fan out first. And it can be a little particular. Now, in I know Charles File, when he was here, he would sometimes what he would do, his active route likes to go around in different ways if you don't use a route guide. He would just draw a temporary keep out like on the top layer just to kind of guide it. And so if you're playing around with active route now, active route currently will route the entire net. So in this, when you're trying to route up to the chip, in this case, but it'll also do pin and part swapping. Pin swapping. But it's probably not. I was experimenting with this to see if I can get it to work. But it wants to route up to the entire chip. If we can just get it to route, just before that, and then optimize on it. But it wants to fully complete the route. These just happen to come up to this terminating point. But if you had other routes on the net, so it tries to do the entire route, not just between segments. So that might be an improvement that are going to do down the road. And there's a panel. Now sometimes even if I'm not going to use active route, just go PCB active route here. When you're routing, there's this Meander. What it does, it takes all of the tracks plus if you set it to the width rule, divided by the number of layers, and it shows you the size that it should take if you routed all those perfectly over. So sometimes you can just take a look at what it's going to look like. I'll make sure I'll set this off, and I'll slide this. If this is 100%, I'll slide it up to 200%, which just gives you more room. And if I hit my route guide, see this and start drawing the route of how I want it to go. See, so this is saying, of course, there's obstacles in there. It doesn't really. The route guide doesn't take into account your obstacles, but it's saying if I was to route this perfectly, this is all of my route. Everything should be able to fit into that. And what happens if active route can't fit it in there because it's just doing just the pure math. If it can't fit those in or it can't meander too far out of there, it'll fail some of those routes. So I'll just click on active route here and it probably will fail, and I'll show you. On some of these, it'll shows down on the bottom. It's calculating. It'll throw in some tracks, but it tries to follow that. But the thing is, see up here, I routed up to the top, and these I had already routed and unrouted it, so these are already pin swaps. So it's kind of cheating. So this routed right up into the. Now see, here's one. See a couple of these that didn't route, and you can see it. And, it didn't. It kind of made some things over here, like this one here. It just didn't have room. So a lot of times over here, I can grab this little track and just drag it over onto the side and make some room if I'm going to try to route that. Because you want to make sure there's enough room for this to come down. So if I control click, I can use my left and right brackets. So if I come over here, control click on that. You can also shift control click if there's a couple things. I'll hold my shift and control. You can click on a couple of different shift control click, and you can get add items to your dim. And now also, if you hold your shift key, it gives a little, it'll highlight called live highlighting, so you can kind of see where things are. It'll highlight the entire net. This would always be on by default, but the flashing annoyed, was annoying. So this way you can hover over, just shift, click, hold your shift key, and it shows you where those connections are going, so you can get a mental picture of how you're going to route that track. So like in this case, I've got. This is coming over here. If I wanted to route down, I'll just hit UT. This is where I like a hug and push. And I've got the clearance boundaries enabled, so I can kind of see wherever it's kind of washed out, that's the clearance. I can't route in there, but of course you have hug and push modes. So, but a lot of times if you don't have room to push and you're looking in there and you kind of get a visual, you can turn that on and off. I think it was Control W. So if you don't want to see them, so then you just Control W turns it back on. And with the hug and push, I could just come right down in here, and it'll push all of the all the other tracks and other things up. See this? Except up here, see these went up around over that, so I'd have to pull these down a bit. See, and even when you're dragging it, it applies a dim intensity. So and you can just use your left key increases the intensity, and your right, actually, that's dimmed too much. See if I get it back. It's going slow. So you can change the intensity. I think I pressed it too many times. So as you're dragging, Now see, here's this little track segment I left before. See, I've got this little segment over here. If I click on that track segment, hit tab, it'll select the entire length of that, then I can just delete it. So then, see, like here's one of those little, see this is not in the same plane, so you got this little vertical nub on there. So if I just drag it a little bit and let it go, then it'll optimize that into a single track.
The glossing be the same thing?
Yeah, so that's the glossing effect.
That's because you have glossy.
Yeah, and so then, yeah, so right now, see in 80, see I have 8019, and when I hit the tab key, it just changes the selection. I have 8020 up just to show you real quickly. See, and so in 8020, which see when I'm dragging this and I hit the tab key, see now we have the interactive sliding. So it's a function we really miss, so we've got to wait for that to come out. So it's really, really, really useful. And also it shows you the glossing effort and other functionality. So I think, as I found that this part, especially the end of your, a lot of times you'd be sliding tracks around trying to get things to fit. And it's just as...
With tracks that are not at a 45, they're at all angles.
Right.
And I have trouble going back in and modifying traces that are at an all angle. Is there any tricks to helping me when I initially lay a line, I want to lay a bunch of parallel lines at that same angle? Is this hug mode? The hug mode?
Hug will help in there. There's sometimes there's a new follow contour mode, which it's a little tricky. I don't know if it'll do exactly what you want. So when you're routing, but this is more follows the contour of an object. Probably that hug mode would be that way. It'll more hug that if it's at an odd angle, and that's what 80/20 is. One of the focuses is any angle routing, just to try to improve. Yeah, especially when you're pushing. Yeah. So there, especially with the new kind of snake routing. So it's still got some quirks on there when you have any angle, but it's getting better. So now they have this contour routing, especially if you have rigid flex or others, which will follow the contour of an object. Like if I hit, I'm routing up here. If I hit Shift F for contour mode, then you click on the object. See, this will start following up the top of this arc up at the top here. You could also do, let me just see if I could change the intensity a little bit.
The workaround for what you want to do is sometimes copy your trace at the exact length, right? Try to trace the distance, and then you can copy from the endpoint to endpoint, and then you have a bunch of parallel traces, and you change the net name, and now you can join into that odd angle. So that's the workaround for what you want to do with 19.
Well, I'm using 20. I'm already using 20.
So you can like place a group of tracks at the right angle, and then assign the net name to them, and then it'll stamp to it. Because it won't they want to do a 45 if it's a weird angle.
Yeah, exactly.
But sometimes you might have some board that
And also, and also in 20 they have that mixed mode where it's because in where you've got when you're routing in 20 and you hit tab, now they've got the 45 rounded or kind of a mixed, which allows you to do that more any angle and tangential arcing. So you want to make sure, you want to have the alpha 5 and make sure you try mixed mode. All right, so let's go to the. So the routing boundary, when you're routing, it's just see if you hit it's going to be Control W, but it's going to be the routing. It's going to be the routing boundary. It's just Control W. It's right here in the middle. It's show clearance boundaries. So you just hit the tilde, the little accent grave, and you can turn that on directly from there, or using Control W. All right. So now in our examples that we give, of course, there's the mini PCB multi-board project, which when you look at that, it's really good of a lot of full projects. I mean, a lot of good examples in there. I like to start even if you're newer to Altium Designer or you want to get a good example, is open up the Wi-Fi Mini. It's a lot smaller example. And this just shows you how fast technology changes. I was looking at this board and the little Wi-Fi module that's on here, it's already obsolete. So, and I had thought that maybe I would show, because a lot of times, that's our job. We'll get, something will change and we've got to change it out. And I was gonna, one of these I don't know if it's on this one, I was experimenting. I said, well, let's try to change it out. So I found another little replacement module. But I figured that I would just stick with the, I thought it was cool because it had a really nice 3D graphic on it, but I just decided that I would stick with the original. Where's my Wi-Fi? Okay. Now, of course, polygons. Now, polygons could get in the way, so you want to make sure you go to Tools, Polygon, Pores. Now, if you shelve your polygons, and see, these are shelved, so you want to get them out of the way. Of course, there's when you route, if you don't have the auto pour on, you have to re-pour your polygons, and sometimes, and that can work, but sometimes it can get a little cumbersome as it's re-pouring. So there's the option here in your preferences for the auto re-pour. Let me get out of, see, this is going out of that mode on this side. Okay. So if you go under your PCB editor here, I think it's under General, they've got this re-pour polygons after modification. And so as you make a change, your polygons automatically re-pour. But if you have a bigger design, that could cause a lot of delays, especially if you're making a lot of little changes, waiting for that polygon to re-pour after every time. So one way is just to go ahead and shelve them. Except if you shelve a polygon, if it's connected, it will it'll hide the connection line. So a lot of times, I don't know if there's an extra trick to stop that. If you unpour the polygons and then shelve them, then it won't hide the connection line. But once you shelve them, if it's connected to the same net and it's going somewhere, it's showing that, oh, that's already connected using the polygon. So in this case, let me just shelve these polygons. Well, down at the bottom, now in the original example, it didn't have a cutout here. I was reading in the PCIe data sheet, and it said that you should get rid of the copper on all of the layers down here. If I go in single layer mode, so all of the layers under the fingers, and so I put this keep out around here. But the way that you can see that the original design, they assumed that the polygon was going to come and just connect with the thermals. And in order for that to happen, the polygon has to come in, this keep out has to be below the midpoint, otherwise it doesn't connect. And so many reference designs I've downloaded and played with, the polygons are always the worst. And you always have to add little segments and things. And I prefer something like this of adding little stubs out. And that way you could say these need to be connected, and it gives a nice connection point for your polygons. Now, there's also a stub check in your design rules. So in this case, if I just shift click on these ground, so you have to hold your shift key down, I can then, and my polygon's in the way so it might not work, but if I hit the U key for interactive multi-routing, if I try to, okay, let's see, it's letting me routes right up. Let me hit Control D and change my, oops, I have to hit my, so I wanted to change my polygons intensity a little bit. So I'll just hit the interactive multi-routing and then route these up, just little stubs out. So it's the same thing on the bottom. So then that way, when you re-pour your polygons, it gives a little stub. And you'll see that they've done that. When you look at the mini PCB, they've done that because a lot of times if you have a big BGA style chip and you're fanning it out, the polygons like to sneak in there and pour, and you'll get, and you want to keep your polygons away from the balls. There's been, I guess, studies where the heat can cause the degradation around the solder mask. So you want to keep a lot of times when you read the data sheets, they'll say keep your polygons away from the big chips. And so then you put a big keep out area around your chip. So for example, but then you have that on the ground pins around the edge, they won't connect to the polygon. You run into the same problem. So you just extend little track segments out so the polygon connects. Just for example, 46. Now I'll bring, let me get this. So here, now just like, so as example, here's this port keep out is around here to keep your polygons out. I wanted to show just on this talk a little bit about Fanout. This is an older, I think it's like a Vertex 4, which older chip, but a lot of times, see, I have my draft mode on. I can turn that off if it makes it a little easier. So let me turn my. Let's see. So right now remember before I set my custom mode, because I had set these up manually, but I'm using a custom configuration. So I've opened up a new PCB, and now I have my TRAN up here. So I can click on that, and that'll show me. It'll show the settings that I had configured. So I have all these little net antennas. A lot of times if you run your DRC and you want to get rid of those, you have to just go to Tools, Reset Error Markers. That'll get rid of those violations for you. Now for the fan-out style, if you go in and right-click on a pad and go down to applicable unary rules, because the fan-out is targeting just a single device, so it's going to be a unary rule. So when you check the unary rules on one of those pads and scroll to the bottom, it'll show the fan-out style. Now, it calculates if it's a BG or not. It looks at the number of pads and if it's symmetrical. So a lot of times chips will have like fiducials in them, or they'll be missing pads, and it won't get caught as a BGA. Right now it's using fan-out BGA, but it'll use the fan-out default. And so what I see a lot of designers do is they'll go and they'll change their default to the fan-out style that they want to use, which of course there might be different chips and things. So in this case, so when we look at this chip, it's missing some pads, so it's really not symmetrical, and so there's really no easy way to say, this is a BGA. There's no like is BGA. There's a couple ways. You're going to create a class and say put in a BGA class, or you can target the footprint. For example, so this footprint, if we look at the properties of that is, I got the region, but let me go selection, filter, and just go to components. And so that's going to be this it's going to be F66. Well, it's got the Xilinx chip. So when we look at the design rules for that, under routing, you've got your routing fan-out control. And see, when I clicked on BGA, so I already set it up here. The default just says is BGA. It says does it have, I think it says in tech docs a minimum number of pads, but if it's not symmetrical, it throws it out. So I put in this or has footprint. So an easy way to do that, see if you don't want to lose what's in there, so you just go to this query builder, and from the pull down, you have the associated with footprint. And then you can choose your footprint. Or if you have probably a better idea is a component class. So you can say is BGA or in component class, and you have your different component classes there, because you might have to do that for different. It looks at the pin configuration of each of these and tries to determine if it's that device or not. Otherwise, it ends up in the default, and it'll use whatever's down in the default area. Now for fan out, like there was a question earlier, like sometimes it just fails. What happens? Now, a lot of times, if you see like this one, all of these down at the bottom, there's all of these coupling caps down under there. Or if you have routing another layer. So now with the coupling caps here, because it tries to go in and figure things out, but it's by the book, exactly by the book. So when you have these different coupling caps or things on the bottom, obstacles, it might not fan that component out. Now, over at FedEvil Academy, they have a really nice kind of advanced PCB design type thing. And when you do that, now he has you go through and place all the caps. It's a wonderful experience. But that's one of the most challenging things is getting a lot of times when you look at it, it's going to vary on the device, whether you have your different channels. If you have 4 different channels, if you're putting them down the middle, then to get your fan out going. So you can try a fan out, but it's by the book. It takes this based on, you do have some options in the design rules for your BGA. So if you're going to do like a via in pad, you've got your under pads that's set here. Otherwise, you've got a BGA style. I had a via in pad. Like if you're doing if you're going to do a micro via with vias and pads, now we don't really have it set up for micro via style. So what I had experimented earlier, I did via and pad, routed them all, selected all the vias, and then changed the via style to drop down one level. but then it doesn't stack them up too. So I copy them, paste them, change their layer range, and then paste them back in there. There's one really nice function in copy paste is when you paste an electrical object onto, like a via onto a track segment, that via will pick up the net of that track. So it makes it really easy to copy and paste around here to finish your track segments. So then you have your direction from pad, away from center. You have the different directions, also towards center, so we'll do away from center. And do you want it centered between pads or close to the pad to follow the rules? And I'll choose center between pads because I had unrouted this one and left the items on the bottom. And then we'll just try the fan-out capacitors on the bottom. And then we'll do the route fan-out. And you choose component. Now, when you're fanning out a component, it has the option of fanning out pads without nets or not. So you have that option there, as well as if you're going to fan out the outer 2 rows. If you're using pin swapping and you want to leave those outer 2 rows disabled. Now, I've read of some fabricators, they say that if you're doing like with microvias and kind of an inverse pyramid, I'm not a real expert on that, they say you can just leave the outer row because now you're dealing with less vias. So we only have the outer 2 rows. So I was experimenting with that. I just went to fan everything out, and I just set my selection filter to vias and just deleted that outer row. So I'll just leave this with the defaults and click on here. I've got my, let me clear the violate error markers. So this will drop the turn off the. So this will try to fan out different things, but you can see there's some ground pins and others. It's really not a smart fan out either. Like as I mentioned before, it's by the book. So like for example, if there are certain pads that could be routed to the same fan out via, it won't do that. So even if you do run a fan out, it usually requires a bit of work to get things lined up. But you can, and see, so this had this via, this grounding. It had the capacitor down on these 2 capacitors on the bottom, and so that's why I didn't know what to do with it here. But when you look at the original example, it was fanned out, so maybe they have a lot of, you can tell they did manual work in there when you look at the original example. So for example, if I wanted to, I could even grab an existing fan out. I've got my selection filter on. So I can even grab, it can be any net, or you can keep some off to the side. I can get this track and pad and copy it. If you click right in the center of the pad, see I'm snapping right to the center of the pad, and if I hit Control E, that's because I've got, I also have track, let me turn off track, these vertices, but if I have pad centers and via centers, that way I know I'm going to snap right to the center of that pad. As when you copy, you have to choose the selection point. Now I can come over, and if I'm going to paste that somewhere, I can then come over, like over here, hit Control V, and let's say I wanted to put this right in there, although it's pretty close to that cap on the bottom, but just as an illustration. Oh, now it's, let's see. That's because I have my polygons on. Let me turn them off real quick. You see it, so it, see it, and now since it picked up the ground that I pasted it on, but it also was, it's wind violation. If it hits multiple, if it hits, let me just get rid of those. So you can come in and you just hit Control V. You can rotate it around, so you can. A lot of times you can also change the default rotation angle. You can create it with different angles. So you can have more. That's done up in the preferences.
Derek, this is an issue with 19. It used to be you dropped a trace and a pad down, it would pick up as a priority any signal that was routed. But now it seems to pick up the ground plane, or if you have a polygon, whatever's like
kind of priority. Okay.
Up.
Yeah. So
it used to handle that a lot better, and with the upgrade to 19.
Okay. Yeah. Make sure that make sure you comment on that, because it should be because this is important. This is a real because this is a real important function where it picks the so this way you can just.
You want it to pick up what is the active net underneath it, or at least give you a choice, and sometimes it just...
Yeah, and sometimes it'll pick up a connection.
Okay.
Yeah. Maybe get with me later and we'll can make sure that that's like that.
Flawlessly, and
Ah,
it looks
yeah.
like a paint.
Yeah, so you can see this way you can paste these down, and so if there were different nets you need to consolidate, so it's still a lot of work. So I think that you'll find. So, but for Fanout in here, so it's.
You didn't show it, but another way is to just like, you can copy and paste these into an array and then you do the whole,
Oh,
get out
yeah.
the whole thing and then delete
Oh,
off.
yeah,
what you
now,
don't want. That would be
I
like
think,
another
yeah,
way to
and thanks for reminding me, because sometimes if you have a standard chip like this that you use quite a bit, there's a function called Snippets, where Snippets doesn't really work very well with components in Fanout because you have to match those components with your schematics. And that's a major challenge, so hopefully that'll be addressed down the road. There's different workarounds with that. So, because you have to match, match them up with designators, and it's hard to. So you have to use unique designators so that when you drop them in, you can match them with your schematics and then re-annotate them. But with a snippet, there's a panel called Snippets, and in here. So in the snippet panel, so once you have everything the way that you want set up, then if you go into your filter panel up here, I can then turn everything off except for like vias and tracks. I'll make sure that I only have my signal layers on, and then I can just drag around under here, and it's going to select those tracks and vias. Now you can set up a custom folder on your network with different snippets. I know there's been some requests of those of you using the Vault to allow putting snippets into like a version control type thing. And so if this is on your network, I guess this is the Era 10. I made a copy of this, but before I think that's on the other version. So if you had a fan out and you just wanted to drop it in, you can copy it and then you just place that down. And then when you're placing it in, then it will. And it's a good idea to turn off your online DRC before you do it otherwise. But then once you drop it down on those pads, it will, I won't do that one. That was for the main PCB. But then when you drop it down onto your chip, so you want to make sure that you decide on a hot spot that you want to paste it in. So so this one doesn't have a bottom left corner, so if you maybe choose a fiducial point or something else, so then when you paste it down in there, it pastes on top and it automatically picks up the net from that pasted, from that snippet. Or you could even just put in like a bunch of your favorite vias and other things, just paste them down into your board so you can have it as a little scratch pad. And you can set your folders over here. You can choose wherever you want and choose you can add a folder, put it on network drive or something that gets backed up. Okay. Now I want to talk a little bit about link matching. And so and just the way, and a little bit about how these between signal links and routed links. Now, of course, if you don't care about link tuning or anything, it doesn't really matter. You can route it. But if your links once you get higher speed becomes a factor, then you really have to start thinking about if you are doing any kind of link matching, it becomes a big factor. Now, in your PCB panel, so in here, I have some differential pairs over here, and I just have a net class A over here. And in the design rules, I have it set up so for the length matching. So down under high speed, you have these match link segments. And so in here, so for net class A, so I said grouped match links. So it looks at all the links in there, and it takes whatever's the longest one, and then it uses that you can drive all the other links. Now in here I had set up some XSignals, but before, let me just change it back to see if you have diff pair class. I've got a diff pair class that just has those diff pairs. So you can group now, and with a differential pair, you have the option between individual differential pairs if you're going to tune between those, or the individual segments within those. And I wanted to show a little bit how the difference between the signal length versus the routed length and how, so I'll just change it back to net length. So you can see here with this differential pair, see without using XSignals, what happens, I'll just go over here. So with this differential pair, you've got, see all of these have a signal length calculated in the single signal length column, except the differential pair, let me just get rid of that. It's not, because it has an extra component here. So as soon as you have 3 pads in the calculated path, it can no longer calculates that signal path. It's only looking at between 2 pads. And then once you get the 3rd pad in there, now it's going to use the physical routed length. So that's why in here you've got the, for this differential pair, it says NA for the signal length, and then you've got the routed length here. So if I was to length tune this differential pair over here, yeah, that's the same. That's the longest one over here. So if I was going to length tune over here, you'll see that when it looks at the routed length over here, it's using the see this at the end of this, so this the gauge. So you set up your length matching rules, everything in the design rules and your tolerances. And since that length rule says whatever's longest, I want to match everything within that tolerance to that object. But now you can see here it's using 1743 as the target. And see here for the signal length, it's not using the signal length, but it's using the routed length. And so it's important to understand that although there's an enhanced signal length calculation that they're doing in the net panel they've introduced, but it's only between 2 pads. If you have 3 pads or more, or if you do length tuning across components, you need to use XSignals. So the same thing for, see over here, I've got this routed path, just as an illustration, I put a big fill behind it. See, so this comes up and over, and so that's going to be, that's A1. See, so right now, it's using the signal length. See, so with the signal length, it's going to come right across, and it's going to zip across the bottom of this fill and down. So the signal length is 1169. So if I was to, got my, so if I was to length tune that right now, so I added a, let me just go in, to get rid of a length tune, you just hit UT, or you to length tune, and you route across it. So if I was going to length tune this segment, I'll hit, now this will be the interactive tuning, or not routing, but interactive length tuning. And so when I'm routing here, it's going to grab the, so right now it's grabbing 1169, which is 1169 is the signal length. So again, that's going to, the signal length of A1, it's going to shoot right across, see the fill. So if I was to put that in there, and it adds these little accordions that you can move. In 8020, they're optimizing them so they're not as big. So it's you have these accordions. With the accordion, you can drag it. It automatically lets you scale your length tunings. But now you can see that my A1 and A2 are now, they're not yellow because they're within tuning range. But now see, I've got this little resistor over here, and it's not, I don't have a net on it. So if I assign this to A1, so now, see, it's not even connected. Before I was going to have it connected and show. See, it's not even connected. Now you can see over there that the signal length turned to NA. And A2 turned yellow because it's no longer in tune, because now instead of using the signal length, it's using the routed length. So it's, and yeah, I even taught XSignals last year, and I didn't realize that the tuning is based on the signal length, and it'll swap like this. So it's really, really important. I wanted to point it out that it's just because you can see the length now changed. Just even if this is not, because whether it's on that signal or the routed length. So now with an XSignal goes across, if you create an XSignal, always uses the signal length. So if I click this little segment here and I hit the tab, I think I already have some XSignals set up, but I hit tab, and I'll hit tab again because you really want to get, if you have more pads over, you really want to get the 2 pads selected that you want to create the XSignal for, and then you can right-click and choose under XSignals, you have create signals from pins. They also have a wizard, so if you have, like if I wanted to create X signals between all these two paths, you have the source component and the target. It'll create X signals between all those objects. But otherwise, you'd create X signals from pins, and then that'll, it's already have, and sometimes you just have to click on them. Now with the wizard, you can, it allows you to assign X signals to a class, which is, otherwise it just creates an X signal. You have to manually assign those in a class, which I created those earlier. See, under design classes, X signals, see I created, there's diff1 and diff2, which I put these in there for the differential pairs. So if I go back to the design rules over here, I can then change my diff pair to use my X signal class. So now I'll choose my, see I had diff1, I'll just use, now diff all is going to use all of the differential pairs. So I created for each differential pair, I created its own X signal class for those, and I put them all into a class. So what it'll do down here, so if it'll ask me, do I want to look at group match lengths or within differential pairs? So within a differential pair, it'll look at each segment. So you're tuning the positive to the negative versus the group match length. It looked at the length of all of the differential pairs to allow you to make sure that each pair is paired to itself. See, so now with these here, so it's NA here, so it's but it's gonna use the signal length. Actually, let me go to X signals. So here I have. So now over here I've got the signal length is calculated for this, even across this pad now for all of those objects. And if I was going to add a interactive differential link tuning over here, see, so now if we look over here, it's targeting that 1743, and 1743 over here is the longest route over on that side. Of course, then in the you have your different accordion options. You can change it to mitered or rounded, and you can adjust the size of those and the angles. So now, and this is where it's good to have a simulator. One of the guys we're talking with, he said, they had rounded in there, but they ran it through Sigrity to kind of check their reflections, and they found that using mitered in some cases it works better than rounded. So it really depends on your design of what the best style, because a lot of times you just automatically say, oh yeah, serpentine, we'll just use that, it's the best approach. But that's why using a simulator is good to validate some of those. Oh, yeah, they're working in 19. So I mean, in 20 they're working, because in here it doesn't add the accordion. So they're working on that to allow for diff pairs. So that's good. And if you want to get rid of them, you just have to route through it and redo it for differential pairs. So you just I'll just hit the U key and interactive differential pair. You just click over on one. You just click on one of the routes. You just click right over, route right through it. And with the remove loop, it'll get rid of it. Then you can go back in and add that over.
Do you have a way to do the accordion only one way instead of having it centered on the trace?
You can change the direction. There's an option to change it, but
or the Y, so
right.
to go up first.
Oh, I see. To go
Go down, I want it to go
and I see. Yeah, I think if it tries to fill in, I don't know that exactly, but I know you can toggle the direction. Sometimes can help. Sometimes sliding it a little bit, and once it's created. Now the differential pairs, since it doesn't have the accordion, it's not as. Let me just do a diff tuning on here. Yeah, because see so if you wanted it to go down instead of up, well, see, because it uses the spacing. So I guess whatever kind of predefined spacing, but you do have that.
It's fine for the first one. I can get it to do what I want.
Oh, but you want them all up, all up.
Go the other direction.
When you want to nest
Right. So they're just all in one direction. Yeah. Yeah. I think if there's not enough, yeah, I don't think on that there's a. So they have that one pop up. I don't think they're working on some different patterns in 20. I think I think Maxim Borzov might even show some of those, but they've got some different tuning patterns and other things like that. So it's something they've been working on. They might have a way to do it. Yes.
Normally, I just place a trace right next to.
Oh, yeah. Oh, yeah, right. Yeah, so you could place, if you have obstacle on there, because it won't, it's one way to kind of trick it. But all right, so I know that we don't have I think we're coming up on, and I'll just open up for questions. No, it's.
Awesome job, thank you.
All right, thanks. But I think I had a appreciate it. Thank you. I really appreciate your patience. I know that routing is a tricky thing. It's just get in there and doing it. So hopefully you got at least one or two little tidbits.